So for our next fireside chat, I am very pleased to welcome IDE's director, Professor Erik Brynjolfsson, back to the stage, joined by Daniel Kahneman, Professor Emeritus at Princeton and Nobel Laureate. Among his many prestigious affiliations, Dr. Kahneman is a member of the National Academy of Sciences, the Philosophical Society, the American Academy of Arts and Sciences, and he is a fellow of the American Psychological Association. Please help me welcome them to the stage.
I was a little worried there she was going to read all of your awards. There would be no time left for our panel. But welcome to the stage, Danny. And we had, I'm so glad you could join us here. We had a good time just now listening to the last panel. I think that's a good place for us to pick up. It was about the biases of humans and machines. You are, I think it's fair to say, the world expert on human biases, having more or less developed the field. A lot of economists are very jealous because while you got your Nobel Prize in economics, you were just telling me back there that you never bothered to take an economics course. That was probably an advantage. But so one question we can dive in, picking up on what we were just hearing, that fascinating panel and all the insights from that, is we heard about algorithmic bias. We heard a little bit about human biases. You know something about both. In fact, I know you're writing a book on some of this. What do you see as sort of the, let me put it one way, what are the bigger risks, the human biases or the algorithmic biases?
Well, I mean, I think it's pretty obvious that it would be the human biases
it's pretty
the
obvious.
bigger risk. In the sense that what happens with algorithms, you can trace, you have, and you can analyze much better than you can when you're talking about decisions of humans. So I would say human biases are the real problem. There was a very interesting issue that was raised here about a firm that is very sexist. Mm-hmm. And so if you're predicting success in that firm, mm-hmm. You're going to end up penalizing women. And that is undoubtedly true. Now, what should be done?
If you use an algorithmic system.
And if you use a valid system, mm-hmm. that is, if you use a system that is designed to be as predictably accurate as possible, you are going to penalize women because, in fact, mm-hmm. They're penalized by the organization. The problem is really not the selection, I thought. The problem is the organization. So something has to be done to make the organization less sexist. Mm-hmm. Mm-hmm. And then as part of doing that, mm-hmm. you would want to train your algorithm. Mm-hmm. But you certainly wouldn't want just to train the algorithm and keep the organization as it is. The key problem is the organization.
Yeah. So humans have a lot of biases as well, and so we want to get deeper into addressing those as well. So right now, actually, you're working a bit on a new book, on noise,
yeah.
What it's called, that's right. And you were talking a little bit about the different kinds of mistakes people can make. There's biases and there's also noise. Help us understand that a little bit.
Well, the motivating anecdote, I mean, that really started this book going was a consulting job that I did with an insurance company, and where we measured what technically is really called noise, and we did that in the following way. We had them construct, this was really done by the underwriting group itself. Mm-hmm. We had them construct a series of 6 completely realistic cases, mm-hmm. and then they were given to 50 of their underwriters, and they were required to treat them as they would an underwriting job in their regular routine. And they evaluated them. So we had a lot of evaluations of the same 6 cases. Now, the statistic that we computed, it's very simple. You take any pair, or you take all pairs, all possible pairs of underwriters, we had, say, 50, and you compute the following statistic for the pair. You compute the average of the dollar amounts that they gave, you compute the difference, and you divide the difference by the average. So in short, in percentages, how much variability is there? Mm-hmm. Now, I will ask you to think about what would you expect that number to be in a well-run organization? And that was a well-run organization. So the number that you get when you ask that question is somewhere 10 or 15%. 15% looks a little large, 10%. We expect people not to agree on matters of judgment. I mean, that's the definition of judgment, that people are allowed to disagree. But how much are they allowed to disagree? So the executives there were saying about 10%. The truth is 56%. Wow. That's the amount of noise, both among the underwriters and among claims adjusters. It was 56 in one, 58 in the other. That's a lot of noise. And it turns out you have a lot of occupations where a single person makes decisions on behalf of the organization, you know, like a triage nurse in the emergency room, she makes decisions. And it turns out that if you have a lot of noise, that sets a ceiling to how accurate you can be. So noise is a mistake. If you think of shooting at a target, there are really two kinds of errors that you can make. You can be biased, and so you're shooting, you know, northeast of the target. Or you can just be shooting and scattering your shots around the center. That's noise. So those are two very different types of
But there are things we can do to reduce both of them.
Well, it turns out that noise is much easier to measure because you can measure noise without knowing the correct answer. Right. You can't measure bias without knowing some ground
Something's
truth.
completely unbiased but very noisy, then...
I mean, but you can, it doesn't matter. You know, the underwriters, we had no idea what's the correct answer. All we know is that that variance, that variability is extremely costly to the organization.
Right. So what can you do to reduce noise?
Noise is much easier. The first thing that you can do is you should ask whether you need those people. And whether, and whether, in fact, an algorithm could do better. And at least in one of the cases...
How would an algorithm do better if it's working the same information?
An algorithm has the big advantage that algorithms have about humans is they don't have noise. So you present them the same problem twice, you get the same output. That's just not true of people, even when you present the same problem twice to people. If they, you know, if you manage to set it up so that they forget the second time that they saw it, they'll give you a different answer.
But you'd want to train the algorithm on lots of data points, not
of
just
course.
pick one of them.
No, not even that, because it turns out that you can build algorithms that are equal or better than humans without collecting any data at all. And there is a kind of a predictive algorithm that, you know, they're called unit weight algorithms. So you take 6, 7, 8 dimensions that you are pretty sure are correlated with the outcome. And you give them equal weight, which can be done, you know,
Right, that's easy
all you need to do is know the mean and the standard deviation so you can equate the weights. It turns out that formulas that are constructed in this way are about as accurate as multiple regression formulas.
Even though some of those dimensions may be relatively unimportant.
Well, I mean, you select them to be as important as possible. I mean, I call them...
But they're not equally important.
I call them reasoned rules. And you don't know exactly what the weights are. And the correct weights depend in very complicated ways on the correlations among things. So unit weight turns out to be a remarkably robust kind of algorithm. And the comparison between those and multiple regression turn out to be, I think, basically in favor of unit weight.
Yeah. And so that's a way of going. And this also suggests that you may be able to combine humans and machines in different ways to get better outcomes.
Well, yes, I think you can combine humans and machines, provided the machine has the last word. Because what we do know, humans have a lot of valuable inputs to provide to a formula, to a predictive formula. They have impressions, they have judgments. But what humans are not very good at is integrating information in a reliable and robust way. And that's what algorithms are designed to do. So what you want to reserve for humans when you're using the algorithm is the possibility to override the algorithm when something obviously relevant has happened. So if there is an algorithm who offers a loan to someone, and then the banker realizes that that person has been arrested for fraud, then that loan will be...
And that wasn't in the algorithm's data set, so the human sort of overrides it in that case.
But really, those are rare cases where, in general, if you allow people to override algorithm, you lose validity.
Because they override it too often.
Because they override too often, and they override on the basis of their impressions, which are biased and inaccurate, and noisy. So that depending on their mood of the moment and so on, they will give you different answers.
You're not a big fan of human decision making.
Well, compared to what? I would say that for a job like underwriters, it shouldn't be surprising that a simple algorithm can do just as well. You're predicting things about the future, your information is of limited validity, and there are many decisions that have to be made actually by the organization in the sense of deciding on what percentage of cases to accept, of risks to accept, and how much to translate judgments or evaluations into
What
dollars.
about this concern we heard, especially in the last panel, but people have been talking about it for some time now, that some of these algorithms may have some hidden biases built into them that we don't even realize are in there, and they may be making decisions for now not just one person or a few dozen people, but for thousands of millions of people with these hidden biases built in?
Well, if you have an algorithm that, if it's been constructed by machine learning,
yes,
and then it will have, that's the problem that we were talking earlier. If the definition of success that it is defining is the bad definition, you're going to get disastrous outcomes. I mean, that's clear. We were talking earlier about that.
We will have
YouTube
disastrous
thing.
Outcomes. So why are you such a fan of that?
Well,
approach?
because what's the alternative?
Okay.
If you get disastrous outcome, this is what we were saying earlier. If you get disastrous outcome, the problem is upstream from that. It's with the organization.
The problem is with the training data, which comes from the humans.
That's right.
And throwing it back to the humans, you're just going back to the same problem.
That's your.
Is there anything we can do to reduce? You seem to think that we could do better with the algorithms, though.
Oh, I think that even, so we're going back to the problem we're discussing earlier. If you have an organization that decides to reform itself to reduce its biases, then you will want to change the algorithm. But you will make that change deliberately. You will know what you're doing, and you will know that for a time you're losing validity. But
the algorithms, often some of these very large neural nets we were talking this morning, it's very hard to disentangle how they're making their decisions. They may have thousands, millions of weights that go in there, and so they're not very explainable to the person trying to diagnose what's going wrong with it.
Yeah, that's the problem of algorithms explaining themselves is a very deep problem, and I'm not technically adept to.
But at least, there's some work, we touched on it briefly, about explainable AI is one area, although that's nascent. The other thing I think you touched on earlier is the algorithms could potentially be rerun. You could test it against various specific problems that you're worried about and see if it has those kinds of problems, and then address it, and then you can see if the problem continues to emerge after you've addressed it.
The general problem really is with the criterion by which you measure success, and that the algorithm is trying to optimize. And the conversation we had about YouTube and is really to that point. So there was that article recently in the New York Times about the recommendation engine that YouTube has.
Right, and by the way, this is Kathy O'Neill was making a similar point about Facebook, about these recommendation engines.
So the recommendation to somebody who has shown interest in a right-wing message of some kind, the recommendation will be a more extreme right-wing message. And that is done completely with, just with commercial intentions. I
But
mean, there
I
are
just
no
want to be very
political-
clear, it's not just right-wing, it's
it's
left-wing
as well. I
or
mean-
it's interested in wine, or it's whatever you show some interest in, they show you more extreme versions of that through the algorithm.
I mean, on wine, I wouldn't know what more extreme is, but politically,
Oh.
but
I would.
politically, you do know. So YouTube is polarizing, and which I hadn't thought of earlier, and that's built in because of what it's trying to maximize. If you're trying to maximize the time that people spend on YouTube, this is going to be the result.
So this is not a conscious desire to polarize the American
course not.
people. This is a desire to drive engagement, and therefore they find
Look,
that,
I mean,
that
if-
the algorithm picks things that are more extreme because we tend to be awed by them. And I think Sloan will talk a little bit about
we're
some
more
of
interested in more extreme versions of what we think. So if you
Yeah.
are on the left, you're interested in more extreme left positions, much more than you really want to expose yourself to opinions that you completely disagree with. So that's built in.
Yeah. I was looking again at your book, Thinking Fast and Slow. Your bio said it sold 1.5 million copies, which is completely wrong. Apparently it's 6 million copies, so congratulations on that. And this basic concept of system one, system two, some things we can decide very quickly, some things require more deliberation. In the context of a conference where we're talking a lot about machine learning, I'm reminded of Andrew Ng's 1 second rule. And I think you've talked to Andrew a little bit about this. But Andrew Ng, a great machine learning expert, tried to develop some criteria in his previous company for which kinds of projects would be suitable for machine learning. And one of the rules of thumb he gave people was, if a human can do it in less than 1 second, it's a good chance that we can design a machine learning system to do that. Do you think his 1 second rule for machine learning maps well onto thinking fast, that system one part of our brain?
Well, it maps well because there is an operation of the mind. I mean, there is associative memory. So, when something happens, a stimulus is registered, it evokes.
What are
a
some of
lot
the
this-
examples of things that are in system one that we think quickly about?
Oh, I mean, you very quickly think about causal stories, for example. That would be part of system one. So that, if I tell you that somebody, spent a day in New York and enjoyed herself in the crowd and so on, and then she came home and she didn't have her wallet. Now, people, when they're tested later, they think that the word pickpocket was in that sentence. It wasn't, but it was filled in. And that is something that, a machine learning device.
It actually gets back to our earlier thing, the machines will fill in some of these
Yeah,
assumptions, biases.
It has to.
Okay. We only have a few minutes left before I'll go to questions from the audience. I'd love to get some of your questions on that. But one of the other things that we talked a little bit about was this idea of actually, let me come back to that later. Let's talk about now the well-being and the habituation issues, and whether or not there is a good way to measure our happiness and our well-being through some of these surveys, and whether they're capturing the essence of what makes for well-being.
May I cite your research?
Yeah. We were talking about that, sure.
So I think Erik has shown, very convincingly that there is a very significant consumer surplus of digital goods. So Facebook, there is a large, we need to be paid a lot to give it up, and much more than actually it costs. So that's a definition of consumer surplus. But actually, that's true of heroin as well. So, and what
Heroin,
is
okay.
common to both of these, whether this was a need that didn't exist 50 years ago. So the need has been created, and now we're fulfilling it. But the basic question is, are people really better off? I mean, they're better off economically. And there are certain aspects of life,
They're willing
like
to pay a
child
lot.
mortality and so on, that are undoubtedly good. But are people really happier than they were? This is not at all obvious. And the reason it isn't is that people adapt and habituate to what they have, to most of what they have. So the interesting question, I think, when we think about well-being is, and about providing various goods to people, is whether they're going to get used to having those goods so that it's a blah after a while, or whether those goods continue to give pleasure. And so there is really a difference between goods that adapt and those that don't. And here, it turns out that there are many things, many of them are human contact. Friendship is a good that doesn't adapt. It just stays good. You know, a weekly poker game just stays good. You can do it for years. And if anything, it gets better. So there is a difference between that and things that do adapt. And if we want to sort of improve human welfare or human well-being, thinking about providing more or looking for ways for people to get more of the goods that they will not adapt to is really a worthwhile objective.
It's a really interesting subtle point. So it's not enough to measure GDP. It's not even necessarily enough to measure consumer surplus, what people are willing to pay for. We have to think this next level about the kinds of things that people crave but aren't really giving them happiness versus the things that they truly value.
Yeah, and really the essential thing here is really this adaptation. That is, you know, you can't, I mean, I cannot remember, I grew up in Israel, and I grew up without air conditioning. And today I can't imagine life without air conditioning. I mean, it must have been horrible. In fact, I think I had a pretty good time. So this is a good that creates a need that you adapt to, and not much changes in your overall welfare.
But I don't think you'd go as far as say, let's just pull out all the air conditioners. They're not making.
Oh no, you can't. I mean, because this has happened. I mean, we have the air conditioning, and it's immediately an improvement. The problem is just you get used to it. So we are now used to a lot of things that we didn't have. Now, some of the new goods are, I think, important to things that really matter, like health and longevity, and you know, but those that don't serve those obviously important objectives that we get used to, and then they stop giving us anything, it's not obvious how valuable they are. Although, you know, they could be valuable because they keep the economy going. I mean, you know, people are willing to pay for them.
And people have jobs doing them. And is
Yeah,
that's the real source of the happiness, is that people are
Possibly.
working on that? That's an interesting perspective. Let's get some questions from the audience. Let's see if we can see out there. I see there's one hand there and one over there. So I guess we'll start right here. Bring the lights up. Go ahead.
Okay, you said that, made an interesting point about people naturally adapting and habituating to things that they have. And you mentioned the air conditioner. Do you think that it's inevitable that as, you know, we continue to progress, that our expectations keep getting higher and perhaps are unrealistic? So you can't imagine living without an air conditioner now, because now you know what it's like to have an air conditioner.
Okay, we got that.
We'd have to summarize that.
Yeah, so he was asking that, are we stuck always being unsatisfied, that we get used to air conditioning, and I think that there's a term called hedonic treadmill, and are we sort of doomed to never being satisfied?
Well, I mean, adaptation is certainly something that's built in. And, you know, there are those classic results that, by and large, you know, there is economic progress, but happiness, you know, there are no survey questions that track economic progress. By and large, survey questions show happiness remaining pretty much constant.
So even though GDP has gone up, we haven't gotten happy.
And there is a correlation across countries between GDP and reported well-being.
Right,
It's
richer countries on
perfect.
average are happier.
Yes, definitely.
Although a lot of that happens in the very low end, the poor end of the spectrum, as people are getting the basic needs, food, clothing, shelter. It seems to level off. There's been a bit of a debate as to whether how much it continues to go up, or if it even does go up. after a certain.
Yeah, I haven't followed that at the level of country.
But over time, I mean, this is, we spend a lot of our time and energy trying to improve our well-being, make us all better off. Is that something that is a futile exercise, or do you think that we are able to continue to
Well, I
improve
mean,
well-being?
you know, the point that I was making earlier, if you certainly, when you get air conditioning, if you haven't had it, it's a major improvement in your standard of living. And for a while, you're just delighted with it. We did a study once to answer the question. There was a debate between my late wife and myself about whether people are happier in California. She didn't want to leave California, and I wanted to move to Princeton. So we had that debate, and so I did a study.
You actually did some research on that.
I did some research on that. And we compared students in Ohio and in Los Angeles. And you know, what turns out to be the case is that people are not happier in California, but everybody thinks they are, including the Californians.
And the Californians and the people in Ohio also thought that.
Oh, absolutely.
Yeah.
And so you could imagine somebody from Ohio deciding to get himself happier by moving to California, and he probably won't be happier, but he'll think he is happier because he will remember Ohio, and that will keep the contrast going. So
right.
there are real subtleties.
You're twisting my mind here, but let's get some questions over here. Is there? Yeah, right here. There it is. Go ahead.
You started the talk off by talking about like the dangers or the badness of noise, but Ariana mentioned in her talk session where she got a loan because she walked into a bank, and she mentioned that there is like in no circumstances that an algorithm would have gotten her a loan. So I'd just like to hear your thoughts on potentially the upside.
If you
of
heard that,
noise.
you want me to? So in the previous panel, Ariana Huffington described how she had been rejected from many loans, perhaps through rules, algorithms. Then she walked into one, and that person gave him a loan. She implied maybe he wasn't following the rules or whatever, wouldn't have normally given it to her, but it worked out for her, and look at her now. It worked out as a good decision for that bank too, I think.
Well, there will always be cases like that. There will be exceptions. When you are turning down people for loans, there are some of them who should have gotten the loan. But if there is noisy individuals, I mean, what they do is you take the best prediction, the optimal prediction, and then you flip at random some of the optimal predictions to make them more random. This is noise. This is what noise is.
And could that make us better off? And could that make us better off by flipping some of them away
There's
from us?
only one condition on which a lot of variability is a good thing, and this is if it helps selection. So if there is feedback and selection, that's how evolution
Like
works.
a learning system.
Evolution also. You have mutations, and then they get selected or selected out, and that you want a lot of mutations.
So if you just
there
keep
want
picking the
noise.
same people over and over, maybe you would have been better off trying some new people who then later would have.
Only if you give yourself a chance to recognize it.
Yeah.
So, in fact, that is a very important thing to do for organizations that are selecting personnel, is to keep trying to hire people that they would normally reject, and in order to figure out
To learn.
to learn
learn,
about the validity of this.
Because maybe it's dynamically optimal, even if it's not statically optimal. Yeah. So I think we have maybe time for another couple of questions. I guess there's one back here. Yep.
So you're both social scientists. Could you talk about how you see machine learning potentially changing the process of doing science, and whether it will extend into machine learning and artificial intelligence generating hypotheses rather than just being a methodology that researchers use in the same sort of current process? Like, will we discover fundamentally new things, and will AI actually take on more parts of that process in science?
Really interesting question. So it points out that we're both social scientists, and the question is whether machine learning, how will machine learning change social science, and whether it will, do you think, be able to help generate hypotheses and formulate problems, not just be used to assess them?
And clearly something that is going to happen is that there's more and more big data being accumulated.
Right.
And they will be analyzed, and there'll be a lot of learning. I want to react to something that was said on the previous panel about the ability of AI to decode human interactions, or maybe it was done in the green room and not on the panel. My guess is that AI will be very, very good at decoding human interactions and human expressions. And the reason they will be, if you imagine a robot that sees you at home and sees your interaction with your spouse and sees things over time, that robot will be learning, but that really doesn't matter. What all robots learn will be learned by everyone. This is like self-driving cars. I mean, it's not the experience of a single individual self-driving car. So the accumulation of emotional intelligence would be very, very rapid, actually, once we start to have.
Because you can learn from multiple people.
They will learn from
there was
multiple
an interesting survey about asking, trying to predict how well people would like a cruise or other vacation options. And one of the best predictions was not just what you had done yourself, but what other people like you had done. And if a machine system has the ability to draw on that other information, it can often make better decisions.
It's just in terms of building a predictive. What is going to happen is that those robots inside the homes are going to collect big data very quickly. I mean, there's going to be a massive amount of
So
data.
they have a lot more data, and they can form it. So that might help with making some of these decisions. I still think today, I would be on the side that mostly humans have a huge advantage in the problem formulation, hypothesis, and the machines can be very useful in assessing it. Whether that will, someday, I mean, you can imagine that evolving, but I think right now that's a pretty good division of labor.
Actually, the reason I'm talking about emotional intelligence is that I think a lot of it falls into the 1 second.
The thinking fast, yeah.
I mean, it's the thinking fast. I mean, I'm not talking of, figuring out what the other person's motives are. It's just the kind of intuitive understanding that we have. Those machines are going to have better intuitive understanding than we do.
So that's another thing we can put in the column for machines versus.
I think, eventually.
I think we have time for another question right over here somewhere. Not sure. There we go. Okay.
Yay. Thank you very much. Underlying everything that we've heard today is about the integrity, or for me, it's questioning the integrity, the validity, the reliability, and the generalizability of the data that we're doing analytics on. And we know from the last political event.
So keep the question short. I'm gonna repeat it for Danny.
So what can we do to ensure that when we look at data, like in the last poll, we all thought the result was going to be different. Data is almost self-selected. How do we control for the biases in the way that we're collecting data?
So this is coming back a little bit to the thing we talked about earlier about the biases in the data. Is that right?
It's not just in the data, it's how we collect the data so it's representative.
Okay. So what can we do to address the fact that sometimes data is collected in a biased way and not representative, and address those kinds of concerns?
Well, I mean, collect better data.
Is there anything we can do systematically to address it?
No, I mean, you are going to do that the way that you do science in general. I mean, you're going to try to get data that are capable of
Do you think humans who are deciding what data to collect could?
For the time being. I mean, we clearly some areas that are areas where people exercise judgment today will be taken over by algorithms. How it will go and so on, that's.
But you don't seem very worried that these algorithms will perpetuate biases or even amplify them?
No, I must say I have big worries about algorithms, but biases are not.
What's your big worry about algorithms?
Well, I mean, it's what this meeting is about. It's about what it will do to people.
Okay, like
and
jobs.
Whether it will create superfluous people or whether it will destroy good jobs and so on. So those are the big worries.
Well, I don't want to leave this on an unhappy warning because you always got a smile on your face. So let me just wrap up. I don't think you're going to like this question because I've asked you before, but do you Do you have any advice on happiness? You are a person who's studied this a long time. You're in your 80s, and we're all curious about how we can live happier lives, and you've thought about it a lot. So what wisdom can you share on that?
Well, you know, I've said one thing, which is really think in terms of goods that you will not adapt to, and look for those. And a lot of that is social. And another aspect is if you look at your life, the finite resource is time. And so thinking about how you spend your time, because that's what you got. Optimizing your use of time in some way, that is very important too. So those, if I have to have some advice about happiness, those would be the two pieces of advice.
Well, this has been an optimal use of time, and I'm very gracious that you shared it with us. Thank you very much.